Okay, today we're going to have a look at the square root functions. We're going to be looking at the square root functions in the AHK form. So we have a dilation factor of A, a horizontal translation factor of H, and a vertical translation factor of K. It's really important that for these particular examples, we're going to be dealing with the real numbers. So that means we're not going to be dealing with situations where we have negatives under the square root. Of course, if we consider complex numbers and imaginary numbers, we can deal with negatives under the square root. But for these examples, we're not going to be. We're only going to be considering the real solutions. Okay, let's look at the first situation where h is positive. Now, when h is positive, it means that our function, it's going to have a general form where it moves to the right. Okay, let's just see how that works. So let's have a really simple example where where y equals square root of x minus 2. So let's just do a rough sketch of what that's going to look like. Okay, when x equals 0, what does that look like? Y equals the square root of 0 minus 2. We can't do the square root of negative 2 when we consider real numbers, so therefore our y value in this case does not exist. Okay, let's consider x equals 1. So we substitute 1 in for x and we get the square root of 1 minus 2, which is negative 1. We can't do that when we're considering the real numbers. Let's try x equals 2. Okay, when x equals 2, we've got 2 minus 2 and we square root that. Square root of 0 is 0. We can actually calculate that. So that's the first point we can mark on. Okay, now x equals 3. 3 minus 2 is 1. Square root of 1 is 1. That's also a value that we can consider. Okay, if we can continue that on, we get a nice smooth curve. Once again, that's only a general representation of what this curve looks like. Okay, let's think about now if we were to have a negative h, what happens there when we have a negative h? Negative h, but in the same form. So square root of x plus 2. What does that look like? Okay, when x equals negative 3, can we make that work? X equals negative 3. Negative 3 plus 2 is negative 1. Square root of negative 1. We can't make that work. Okay, in the real number system. X equals negative 2. Negative 2 plus 2 is 0, square root of 0. Yes, we can do that with the real numbers. Okay, so that's why we have the shift to the left when our h is negative. So our h value in this particular case, h equals minus 2. You've got to remember that in the general form, we have a subtraction in the general form. So that means that if h is positive, there's a subtraction in the actual function form, but the h is positive, that means we have a move to the right. If h is negative, that means the function now has an addition in it, and we have a move to the left. So that matches up with how we generally think about number lines, where when we think to the right is in the positive direction and to the left is in the negative direction. So that just helps us match that up. Okay, so when we have in this form x minus h, okay, the graph starts to the left and it moves to the right. Starts to the left and moves to the right. There is another general form. If we have a look at the form where we have the subtraction in front of the x, okay, it's the same graph. We're just considering it for different values for x. So what happens when we have values for x? So in the first couple of examples we looked at, we had a whole heap of values that do not exist. Okay, we can't make them work out when we consider the real numbers. But we know that if we substituted different values into a square root function, we can make them work. So what do they look like? Okay, other thing to consider here, this is a different general form. The h has no subtraction in front of it. So that means that if h equals 4, positive 4, it will just be a positive number there. It has no negative in front of it. So you can actually see the sign in front of the h in this case, compared to when you look at the normal general form where the sign is the opposite of what h is. Okay. Now this is how we can deal with negative values for x. So let's have a look. Let's do a positive h. We'll only do a positive h with this one. Okay, so let's have a look. Y equals square root of 4 minus x. Let's have a look at what that looks like. Okay, x equals 4. Substitute x equals 4 and 4 minus 4 is 0. Square root of 0 is 0. Okay, that's our first value. X equals 3. X equals 3. 4 minus 3. 4 minus 3 is 1. Square root of 1 is 1. Okay. So you see it's moving in a different way to what we would be normally working with in a general square root form. Let's try when x equals 0. When x equals 0, we've got 4 minus 0 is 4. Square root of 4 is 2. Oops. So if we join those dots up, those points up, we get a function that instead of moving from left to right, starts on the right and moves to the left. Okay, so that's why when we have this other form of the square root function, when we have it flipped around the other way, the function sort of flips along around the y-axis. It starts on the right and moves off towards the negative direction. Okay, so if we think about that, just to sum up, if we think about having our axes, just say we were thinking about h equaling 0 and k equaling 0, so the simplest situation that we can have. When h is, when we have the square root of x minus h and a is positive, we start in the center and we move to the right, and it's in the positive direction. When a is negative, once again we have our negative dilation factor. That means the graph flips or is reflected around the x-axis. Now when we have the other form of the square root, when we have h minus x, we start in the center or to the right and we move to the left or into the negative direction. That's when we have a positive a value. And when we have a negative a value, our function flips around the x-axis. So really it's no different from when we have the other functions, when we have other functions in the AHK form. It's just that we have to remember there is one other extra form that we have because of the square rooting of the negative. Okay, I hope that helps. Let me know if you need more of these types of questions, and there'll be more videos soon.